Hello, everyone. After the class on Friday, we were left with a small portion that is not covered. In today's video, we're going to cover that. In last class, we discussed how to compute the total profit of a delta hedged position of a portfolio called V. And we ended up with this expression. And we argued that for a very small change in time, which is denoted by h, so then you expect the second term to be small. And over a short period of time, in general, you don't expect the stock price change to be large. In other words, you expect this first term to be relatively small. So then when you combine them, so the total profit or loss is small or close to zero. Right? However, this is not always the case. Typically, during a financial crisis, but then over a very short period of time, for example, one day, so then stock price can change significantly. And in those cases, even you're that hedged, so then the first term, the stock price change squared, can be quite large. Or in those cases, you might still have a large profit or a large loss. Okay, so then some of you may have noticed that in the first term here, there's a gamma that plays as a coefficient, which we did not pay attention to. And gamma, in fact, plays a quite important role in the first term. Special cases when gamma is zero, so then the first term will disappear. So then your delta hedged position will not be affected by the stock price change. Okay. This is a very special case. So in most cases, you're going to end up with one of the following two cases. Well, the first one is when gamma is positive. So then we can view this profit as a function of the stock price at time t plus h. Then it is not hard to see that as a function of st plus h, this is a quadratic function. You get this quadratic term by expanding this st plus h minus s squared, right? So then gamma here plays the role as coefficient of this quadratic term. But when gamma is positive, when you graph this profit as a function of st plus h, you're going to end up with upward parabola. As you can see, for example, on the left-hand side, the horizontal axis is the stock price at time t plus h, and the vertical axis is profit, right? So we're going to get the curve like this, which is an upward parabola. On the left-hand side, we have the case when gamma is slightly positive. And in this case, you can see within a reasonable range of stock price, right? So then you either have a small loss, okay, that is have a negative profit in this region, okay? Or you have a small profit. So only when a stock price change by a significant amount, let's say the stock price is here, so then you're going to have a large profit. Then on the right-hand side, we have the case with a large positive gamma. And in this case, the profit is more sensitive to stock price change. So as you can see on the graph, when the stock price change is relatively large, let's say here, right? So then you're going to have quite large profit, which is here. Okay. And to many of you, right, you can see this case might not be a problem, right? Because when there's a large stock price change, you end up with a positive profit. So in fact, there are many traders in the market. They're trying to construct a delta hedge portfolio with a positive gamma, such that they can actually gain from large stock price changes on both sides, right? Either when stock price increase or decrease, they're going to have a positive profit. Okay, so then the next case is actually more problematic. That is when gamma is negative. So then when we view this profit as a function of ST plus H, right? Again, here, you can see the coefficient is negative, so you're going to end up with a downward product. Okay. So then on the left-hand side, we have the case with slightly negative gamma. And in this case, as you can see, so you either end up with a slightly positive profit or slightly negative profit or a small loss within a quite large range of stock price, right? So when the stock price change is large, so you might have a large profit, sorry, loss. Okay. But then on the right-hand side, we have the case with large negative gamma. So then as you can see here, and now the profit is more sensitive to stock price changes, right? So as you can see, when the stock price change is relatively large, you can see on the graph that the loss is actually quite large. Okay, so next, let's have a practice on calculating the profit of a delta hedged portfolio. So let's pay attention to this example 6. We are still using our in-class example. That is, we have a market maker who takes a short position on 40 strike call option. Then this call option is actually on 100 shares of stock, right? So let's just record that fact. Okay, so let me say it again. In this course, either in assignment or on the exam, your implicit assumption is an option is on 1 share of stock, not 100 shares. While in practice, options are actually on 100 shares. Okay. So then in this case, we know the current stock price is 40, and we have the delta of call, gamma of call, theta of call, right, and the price of call. And so these information are actually for a long call position, right? A long call position. So when you are taking a short position in the call option, so your delta will be negative 0.5824, right? Your gamma will be negative 0.06507. Your theta will be positive 6.3145. And the portfolio value is going to be negative 2.7804. Okay. Of course, all these numbers should be multiplied by 100, right? So then in addition, you're given the volatility, which is 0.3, and the risk-free interest rate, that is 8%. Okay. So then in part A, we want to approximate the profit after 1 day when the stock price increases by 0.75. So here on the screen, as you can see, I have already done the calculation. So what we're going to do is very simple. So we just record the formula. right? So then plug in the numbers, right? Plug in numbers. So here we are missing a multiplication of 100. Okay, so then as you can see here, this is our gamma, right? Um, you're given the gamma of a call, but since you're taking a short position, right? So your gamma is negative, right? Negative. Similarly, your theta is positive, right? If theta is positive, then your portfolio value is negative, and your delta is negative in this case, right? So then your profit of this delta hedged position after 1 day is approximately 55 cents, right? Well, since it's negative, this is actually loss, right? You have a loss of 55 cents. So then in part B, we have a slightly different case. And in this case, the stock price is increased by 0.6281 after 1 day. So then you just plug in a different stock price change, right? And the other parameters are exactly the same. And also in this case, since our call option, right, is on 100 shares, don't forget to multiply this by 100. Okay. And also, your H is actually 1 over 365, right? What it means is our time is annualized, so 1 day is 1 over 365 of a year. So then if you calculate this profit, you're going to find that this is very close to zero. Okay? Uh, it's not exactly zero, but it's too close to zero such that this is actually can be negligible. Okay? So this is a very special case. So that is when the stock price change is plus or minus sigma times S. S is the current stock price times square root of H, which in this case is approximately equal to 0.6281. So then in that case, so then the profit is zero. Okay, so this can actually be justified by mathematical derivation. But this is a bit beyond the reach of this course, so I just state this as a fact. Okay, so now we're going to move on to the last topic of this chapter, and that is hedging with multiple Greeks. Okay. So as we discussed, so for a market maker who holds a portfolio with negative gamma, when there's a small change in the price of the underlying asset, delta hedging can offer a pretty good protection, right? But for large changes in the underlying asset price, so then large loss may still occur. So then to further reduce the sensitivity to the changes in the underlying asset, so the market maker can actually perform this so-called delta gamma hedging. That is to create a portfolio with both delta and gamma being zero. So then such a portfolio is both delta neutral and gamma neutral. But here's a very important fact that is you cannot construct portfolio that is both gamma neutral and delta neutral using the underlying asset only. Okay. That is because the gamma of your original portfolio is well, either positive or negative, right? But gamma of the underlying asset, let's say is stock, right, is always zero, right? Because you know the delta of a stock is one. So then it's always one, right, regardless of the stock price. So then gamma, which measures how delta changes with respect to stock price change, is of course zero, right? So in other words, by introducing the underlying asset to your original portfolio, you cannot introduce a positive or negative gamma. Okay? So then when you combine the gamma of the portfolio, you still get the gamma of the original portfolio, right? So gamma cannot be reduced to zero. So then what you need to do is you need to introduce another option that can give you either a positive or negative gamma. So then let's do one example for delta gamma hedging, example 7. So you're given the following information for two European options. We call them call 1 and call 2. They are on the same stock. Okay? So you're given that both the delta and gamma of these two call options. Okay? So again, these are actually for long positions, right? And for short positions, you need to multiply the delta and gamma by -1, respectively. Okay? So in this case, your position or your portfolio, right, is a short position in 1,000 units of call 1. Okay? So this is your portfolio. So then you want to construct a portfolio that is both delta neutral and gamma neutral. Okay, so then what can we do here, right? So then to become delta neutral, as we discussed before, you want to introduce the underlying asset, which is this stock here, right? But as I just mentioned, the gamma of stock is zero, right? But the gamma of your short position in 1,000 units of call 1 is not zero. It is actually a negative. Okay, so you want to introduce some positive gamma to your portfolio to make the gamma of your portfolio zero. Okay? So here, what you can choose is this call 2, right? Uh, and also, in this case, perhaps a long position, right? In this call 2, such that you can introduce a positive gamma to your portfolio. Okay, so then let's do the calculation. So as I mentioned, you probably want to construct a portfolio with both the stock and this call 2, right? So then let's assume that you're going to buy X shares of stock and buy Y units of this call 2. Okay, and so then do a calculation, right? So eventually, if you find your X is negative, so then you're essentially taking a short position in stock, right? For example, if Y, of course, if Y is negative, then you are actually taking a short position in this call 2. Okay. So then we're going to set up, actually, in this case, two equations. Okay. So first equation means the portfolio is delta neutral. And the second equation means that the portfolio is gamma neutral. Right? But let's set up the first equation. So your original position in the market is a short position in 1,000 units of call one, right? In this case, this call option, without mentioning that it's on 100 shares, you just implicitly assume that it's on a one share of stock, right? So then in this case, the delta of one call option is negative 0.5825, right? Which is negative 1 times this number. And since your portfolio has 1,000 units, so you simply add them up, right? So there are 1,000 of them, so you multiply that by 1,000. Okay, so then you assume that you're going to purchase or you're going to take a long position in X shares of stock. But then again, the delta of a long position in one share of stock is 1, right? So with X shares, the total delta introduced to the portfolio is X. So then you assume that you have long position in Y units of call 2, right? So then the delta of call 2 is 0.7773. Okay, so then you multiply that by the number of units. And this expression here represents the delta of your portfolio after purchasing X shares of stock and the Y units of call 2. And you want your delta to be 0. Okay, this is our first equation. And our second equation means we want gamma neutral for the portfolio. So then the gamma of your short position in 1,000 units of call 1 is negative 0.0651 times 1,000. Okay. So then, as I mentioned many times, the gamma of your long stock is 0, right? So by adding stock, you're just adding 0 gamma to the portfolio. But in this case, the gamma of a call 2 is in fact positive, right? So then, which is a 0.0746. Then you multiply that by the number of units, right? Which is Y. Then your goal is to make it 0. Okay? So now you end up with two equations, right? So then by solving this system of two equations, you can get both X and Y, right? And this is a system of, again, linear equations. So it's not hard actually to solve this system. Typically, you solve the second equation first, right? Then you get Y. So then you substitute the value of Y into the first equation and you get X. So solving the system yields X equals negative 95.81 and Y equals 872.65. So what it means is you actually short 95.81 shares of stock. And long 872.65 units of call 2. Okay. So then by doing that, your portfolio that includes a short position in call 1, a short position in the underlying stock, and a long position in call 2. Okay. Is both delta neutral and gamma neutral. Okay, so let's move on. So you can actually perform hedging with other Greeks, not just delta and gamma. So far, in all the examples that we have uh, tried, we are assuming that there are three parameters that are unchanged, including the volatility, the risk-free interest rate, and the dividend of the underlying asset. Uh, Over a short period of time, so this assumption is actually valid. Okay, but there are, of course, cases in practice um, in which those assumptions can be violated. And a typical example is during the 2008 financial crisis. But then over a short period of time, then volatility uh, changed drastically. And then due to that change, the value of the portfolio, which is, let's say, delta hedge, can still change by a large amount, right? Because uh, and that change is induced by the volatility change. Right? And in such scenario, when wish to reduce the sensitivity of the portfolio with respect to the volatility to zero, so then one can actually perform multiple hedging with Vega, because Vega measures the sensitivity of portfolio value with respect to volatility change. So we can do an example shortly. But before that, let's just state the general rule of multiple hedging with other Greeks. Okay. So when we do that, basically our idea is very simple. We want to set the portfolio Greeks we are hedging to zero. For example, if we want to reduce the sensitivity with respect to volatility, you just hedge with respect to Vega, right? So then you set the Vega of the portfolio to zero. Okay. And then your hedging portfolio involve actually multiple types of options, depending on, of course, how many Greeks you would like to hedge simultaneously, right? For example, you can hedge with respect to Vega uh, and also Delta and Gamma simultaneously, right? Then mathematically, this essentially means when you are trying to calculate your hedging portfolio, right? So it is essentially a matter of solving a system of linear equations, uh, as we actually saw in example 7, right? In example 7, we want to hedge with respect to two Greeks, right? Both delta and gamma. So then you set up two equations, then solve the system, right? And get X and Y, which is your hedging portfolio. Okay, so then we want to do one more example. Okay, that is delta Vega hedging. Okay, and this will be the last example of this chapter. And you are given the following information for two European options. They are on the same stock. 55 strike call option and 55 strike call option. You're given the price, the delta, and also the Vega. Right. So then the current stop price is 58, and the market maker takes a short position in a 45 strike call option and try to delta Vega hedges it. Okay. So then we want to determine the number of shares of stock and um, the position in this 55 strike call, such that the portfolio becomes delta neutral and Vega neutral. And what we're going to do is very similar to what we did in example 7. We're going to first assume that we're going to buy X shares of stock and buy Y units of 55 strike call option. Okay, so then we're going to set up two equations. So the first equation means the portfolio is now delta neutral. So the delta of your original portfolio that is short a 45 strike call is -1 times 0.7118. And so then by purchasing X shares of stock, you're introducing a delta of X times 1 to the portfolio. Okay. But then by buying Y units of 55 strike call option, you're introducing Y times the delta of this 55 strike call to the portfolio. So Y times 0.4636. And the sum should be 0. So the first equation again means the portfolio is delta neutral. Okay. So then the second equation means portfolio is Vega neutral. Then Vega neutral means the sensitivity with respect to the change in volatility is 0. So then the Vega of a short 45 strike call is negative 0.1632. Okay. So then the Vega of long stock is 0. So then finally, the Vega of this long Y units of 55 strike call is this number, right, times Y. So Y times 0.1951, then it equals 0. So then by solving this system of two linear equations, we get Y equals 0.8365 and X equals 0.3240. Okay. So then the portfolio that is both delta neutral and gamma neutral is a short position in that 45 short call, then plus 0.3240, buying that many shares of stock. Okay. And buying 0.8364 units of this 55 strike call option. Okay, so then the resulting portfolio is both delta neutral and gamma neutral. So the portfolio is not sensitive to changes in both stock price and changes in volatility. Right. So this is the end of the chapter. Thank you for your attention, and I hope you enjoyed the video.